I'm with DP Technology, Esprit, and I've been with that company for, I'm finishing up year 32. So I've been in the industry a long time, manufacturing. When we see part programming, what I really mean is CAM, computer-aided manufacturing. And I got some end users here. They're going to heckle me maybe. But what I'm interested in as I look across the room is how many people here are part programmers? Okay, got a good group. How many are owners of companies who have part programmers? There's one. How many don't know anything about part programming? No, I mean that's okay. Maybe in this hall it's different, but in the real world, nobody. I call it manufacturing clueless. Okay, the people are consumers. They don't know how anything is made unless they watch that show. What's the show? How is it made? Okay, I think it's a great show. So that's the world that we live in. You guys make all this stuff. People use it. They're consumers. The clueless consumers use it. That's all they care about. And that's what we do. We'll talk a little, well, I'm not Mr. PowerPoint. I passionately hate it. So I'll tell a lot of stories, and what's on the screen is really something to prompt me, okay? And we'll talk a little bit at the end if you have some questions. It's nice to see that we have a lot of part programmers. It's very nice to see that. When you show up to one of these things, you don't know if you're going to get, I've been at big shows with 5 people, and 4 of them didn't know what CAM was. And I've been at small shows with 80 or 90 people. So I'm happy to see that we've got a pretty good crowd here. Story number 1. I do a few things in the industry. I'm on 2 AMT committees. So AMT puts this on. I'm one called Global Forecasting, Sales and Marketing, and I'm on another one called Strategic Planning for Trade Shows. I'm on a third one for an organization called PMPA. And if you're in the business, it's Precision Machine Products Association. And every year they put on a national technical conference. And the National Technical Conference is really about very rubber meets the road for guys that might do programming or run machines or things like that. There might have breakout sessions for shop math, just a variety of topics. So I think it was April, I went there. I'm on a committee, but I went there to audit and figure out what's going on and help create content for the next one. And I went to a breakout session. And the breakout session I went to was really recruitment, retention of bringing in employees. So I thought that was cool. There was 3 HR people, or in some cases, or in one case, an HR guy that, you know, he wore that hat part-time and then he did 5 other things. All the companies were about 150 employees. There was one from the East Coast, one from Texas, and another one from Wisconsin. So the Wisconsin HR person, a woman, gets up and she gives the demographics of her company. She says, half of our company, 50% of our company, the age of our employees is 55 or older. She says, we have no one in our 40s. And everybody else is pretty much under 35. She does her thing. At the end, I ask her a question. And the question I ask her, in the next 5 to 10 years, how are you going to replace half of your workforce? Because they're going to be gone. And she, I don't think really knows the answer, but she says to me, automation, robotics, you know, and it's like a standard thing. Well, in part programming, it doesn't work too well, okay? There's too much involved in it. It's tough. Part programming is a puzzle every day, right? There's so much that goes into it. You need a lot of knowledge to be accomplished at it. So here we go. We've got a workforce that's starting to atrophy at the top end. We've got a generation that didn't go into manufacturing at all. And then, if I'll make jokes about millennials maybe through this. And then you've got the millennials, and they want to pick up their phone and program a part. Sorry if you're a millennial, but I'll make fun of them. I hire a lot of them, by the way, so they're great guys. And so what does the part programmer of the future look like? You know, that's it. It's a robot on a computer. And this one's kind of a millennial robot. You know, it's have you ever seen some of the YouTube videos about millennials being interviewed, you know, balancing their life? And then sometimes they threaten you. So part programming, we talked about that a little bit. When, what's interesting, to give you a sense of how difficult it can be to solve the puzzles of running machine tools. Now, when somebody asks me what I do, and I talk about computer-aided manufacturing, and they go, "What's that?" and I say, "Well, it's a software." And what's the software do? Well, the software makes instructions, and I usually define it as for robots, right? So if you look at it, your mill, your lathe, your mill turn, your wire EDM, all those things, they're robots, you know, 3-axis, 4-axis, 5-axis. So that's where the robot lives. You guys, as part programmers, or whoever we are as part programmers, you're the artificial intelligence. You're creating the instructions to make these things run, okay? I feel like you're heroes, okay? It's a tough job. And we got a pretty good group inside here. Now, when I hire somebody new, I have a tendency to hire a lot of young engineers straight out of school, okay? And they're cocky. I've hired people from Ivy Leagues, University of Michigan, some big schools on the West Coast, East Coast, whatever. They come in, and the first thing we ask them to do is program a part by hand. So you give them a simple part like this, and you say you can use your calculator, and you might give them a workbook for trig, and you say, program the part. And all I want you to do is this. It's a little bit, I want an offset, but you can't use G42 and that kind of stuff, so you have to build the offset in. You have to trig out the locations of the tangency points. And in the old days, we had a little desktop mill, and we would have these people MDI it in, but basically punch it in, and we'd all gather around and make bets. We're going to cut some wax. And I don't care who they were or what school they went to, every hot shot that we ever had do this failed. You know, they got to do a GO2, a GO3, and it'd like make these big circles. Oh, by the way, you couldn't use ours; you had to do IJKs. So if you're part programming, you know the routine, right? They all failed. And what's cool about that is it gives them a sense of how difficult the job is for the people who do that work. That's one. Two, it gives them an idea of what the software does for the people who utilize it. And it takes them down a notch, which is always fun. So what's automation? So this is about automation, right? What is automation? What do you guys think automation is? Let's figure out some ideas. Now, sometimes automation just strikes fear in people, right? Automation, uh-oh, it's going to take my job, maybe. But automation can be in baby steps, little tiny things. Here's one that you guys kind of do all the time, and you don't even know it's automation in one sense. So you get in your car, and you're going to take a long trip, and what do? You set your cruise control, right? Is that automation? Sure it is. So every once in a while I rent a car, I get in, I set the cruise control. and I'm not paying attention, and I get up behind the truck, and my car slows down. And the truck moves off, and my car speeds up, and I'm not touching anything. So it's another level of automation, adaptive cruise control. So every car you buy today has at least cruise control. The new cars, maybe it's an option. The higher-end cars, it's by default. You have adaptive cruise control. So they talk a lot about the autonomous cars, you know, and where it makes news is when they crash. You know, okay, fine. But automation has all kinds of things. And for us, when we talk about what we're going to do with automation and part programming, you can go low, medium, and high. Okay? And so as you adapt or you want to do automation in part programming or with your CAM system, and I'm not selling Esprit, I'm up here as a generic, whatever CAM system you have, most of the CAM systems will have the ability to do some kinds of automations, okay? So low, let's talk about low automation to begin with, the baby step. What is it? How does it work? And by the way, automation works with lean as well. Eliminate waste. How many guys are working in a lean environment or an attempted lean environment? Okay, if you probably go, oh God, you know, this is just lean guys. But they work together, okay? If you can eliminate waste and improve productivity, they work together. So, I'll give you an example of lean and automation at the same time as a part programmer or running a machine tool. I have actually, he didn't buy the software, but there's a company here that's exhibiting, and they're in the tooling building right here, and they produce relatively simple parts. And when they do deburring, they've got some guy out in the shop floor. He's got a big giant arm. He's got a Dremel, and that's how they do deburring. Well, in a lean world, you might say that's a lot of work, and in the world of CAM and machining, you might say, why don't we deburr on the machine tool? And in my demo, when I was there, I go, why don't you do this? And the guy goes, wow, that's a great idea. What about the guy that's doing that manually? We got plenty of work. He'll do something else. So that's where you have the crossover between lean and automation. All right, the next one of my favorites is post-processing. Everybody know what a post-processor is? For those neophytes into the CAM programming world, a post-processor takes all the pretty pictures of the simulation and everything that you've done to create this program. You run it through a second piece of software called a post-processor, and it changes it into the NC code. All right? Now, when we talk about machine tools, you're talking about 30 years worth of machine tools with all kinds of controllers, meaning the computer on the machine tool, different vintages, different models, different codes. Manufacturers do different things with them, so you need hundreds, if not thousands, of post-processors. If your job is part programming and your post-processor doesn't work and you spend your time editing post-processing, you're not being lean, that's for sure, okay? And you're certainly not being, what? Automated. So if you have a post and it does what it's supposed to do, you're cool. You're automated now, okay? And actually, we put in a lot of software where we drop it in and it works. And so it goes away. Now, what if your job, and we're talking about the fear now, what if your job is editing the code that comes out of a CAM system? That creates the fear, or could create the fear. Or it could just be, hey, I'm really happy I don't have to do this anymore. So what happens in manufacturing jobs is a lot of times you create dysfunction, and then you create more dysfunction to go with it, and then more dysfunction to go with it. He's smiling because I think you're right. Are you smiling? I understand that. Yeah. And so what you do is you're anti-lean and anti-automation. And so if I was running a company like that, I would go out and hire some automation engineer to start looking at what we did, how we did it, and make changes. And I'm not advocating disruption in those environments, because I think that's a problem too. When I get as I get closer to the end of my presentation, I'm going to talk about some full-blown black box automation, lights out, it just runs. That can be scary to people. All right, so CAM and post-processing. Automation means it does what it's supposed to do. If you have a printer, I remember back in the old days of when I first started, we could only use one type of printer, right? And half the time you felt like you pushed the button, you got the print, and then you had to go draw some lines to make the print right. It's crazy. Well, post-processing should be the same way in the CAM environment. Education. Now, I come from the school of hard knocks, right? Oh, you want to learn that? Go learn it. Well, that's kind of short-sighted, not very smart. But education allows people to be, or to enhance the automation, to be more productive, which is what automation is really about. To give you an example, every single CAM system today utilizes, in the milling world, and in some cases the turning world, something called trochoidal, hard word for me to say, trochoidal high-speed machining. Everybody knows what that is, kind of, sort of? Okay, so it doesn't matter if you're an Esprit guy, we name it one thing, Mastercam names it one thing, EdgeCam names it one thing, blah, 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 they all name it one thing. What it does is you can cut the full depth of the tool, all the whole, entire flutes, very light cuts, very high speed, right? And if you've never seen it before, it scares people. What do you get? Because you understand that you can use that, you get longer tool life. You get shorter cycle times. Now, I was at an open house up in Seattle one day, and an owner comes up, and I had a display showing this kind of thing, and the machine next to me was doing that. And I talk about the technology and how it works. And the guy goes, wow, that's really cool. He's the owner. I say, well, why don't you adopt that? He goes, my guy would never do that. That was the end of the conversation. My guy would never do that. Why wouldn't he do that? It's too fast. It's too different. So part of education is having an understanding of how technology works. Now we're going to talk a little bit. You think this is about technology, this speech or whatever I call it? You can think it's about technology. It's about something different, really. So I'm a tough character when it comes to learning things. You know, I should do more about sending people off and getting educated. But there's so many things about what you know or don't know. And coming to here, I hope you get some education from a variety of these different breakout sessions. The world of automation, let's go into a medium zone that's more Camcentric. So we're going to get more advantage from the CAM system and what you can do with it. Every time I go into a shop, I learn something. I love going into shops. You go, wow, that's what they're doing? That's how they deal with it? What are they doing? It's so much fun. And I've been in some really cool places, whether it's gun makers or whether it's plane makers or whether it's blade makers. It doesn't really matter. You just always learn, which is kind of my thing. I love to learn. So in the world of automation, let's go into medium. What does that mean for me? Do you have API? Does everybody know what API is? Advanced Programming Interface. Now, all CAM systems pretty much have it. Excel has it. Word has it. All the CAD guys have it. What that means is you can go customize it, right? Now, I'm kind of a low-end Excel user. Have you ever seen a good Excel user? You can't believe what that stuff does. So a good CAM API guy is going to plug in a variety of different automative types of routines, low, medium, and high. The first one you might do, well, let's talk about, I don't practice too often on these presentations. So that's okay. It's an intimate group. if you have an owner that says, I took the least productive machine in our shop and I made it the most productive machine in our shop. Now, how did he do that? He hired somebody who had the skill sets to do that. That happened to be Integrex, Mazak Integrex, over in the corner, wasn't doing much. And this guy had he was a job shop, but he also manufactured a series of parts, okay? And so this young guy came out of school and said, okay, I can do this, I can program that. And so they get automation. So the thing over there that's holding down the floor, they make it productive through the API. Now the baby step of API is create an expression. I don't know what either one of those means, but it's a simple string that gets plugged into a field on a technology page that may be for a pocket or some kind of feature that you're going to cut on a part. And that simple string right there will give you automation. It's going to give you the intent that you're not going to have to type in something again. It may trigger several other things, but you've just automated. You created one string. And I talked to a guy yesterday, one of our customers, a very big customer, and he had 3 managers with him of the different plants, and they go, well, what about doing automated types? What can we do? And these guys, they didn't really get it, but they had somebody with him who was a part programmer, hardcore, difficult machines, and he was doing what? He was putting expressions in to the technology fields. I'll bring one up. There's one there and there's one there. So there's a typical technology page. Everybody has them in the CAM. If you put that one string in or you write something special and you save it, it's going to do something automated for you, okay? So what skill do you need? Well, you got to have some programming skills. What kind of programming skills? Not part programming skills, but software programming skills. If, then, else, loop, and loop. Now, we just did one string, but it can get bigger, okay? But it's a baby step. And we did that, we got automation. It's not scary, it doesn't intimidate you, but you got something that's going to benefit both you, the nuisance of click, 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 click all the time might help your tunnel carpal or carpal tunnel, whatever that stuff is. But that's beneficial for you. Second one is no longer an expression, but if I have a technology page, and believe me, when I started 32 years ago, I got to make sure I'm not running out of time here, a pocket page had 5 fields. Okay, 5. A pocket page today might have 250 fields. So if you fill something out based on a certain kind of material or feature, you can save it, you became automated. Well, once again, pretty much everybody can do that. He agrees right there. I'm watching. I like engagement. Okay. PMI, Product Manufacturing Information. Who knows what that is? Well, it starts on the CAD side, typically. Who has problems with design engineers? That's a passion, right? So it's like, they don't, they're idiots. It's manufacturing guys and design guys are kind of like this at times. Who is a design engineer here? So, he's both, maybe. So what happens is, let's take a very simple product manufacturing information that happens on the design side. Anybody got a hazard to guess as to what it is? Hole wizard. That's the easiest one, right? So I don't care what CAD system you're in, you can define a bolt hole circle, a grid of holes all over the place, different kinds of holes, and if you use a hole wizard, the hole wizard defines the manufacturing intent. It's an M6 tapped hole, okay? It doesn't matter if there's 2 of those or 100 of them. You're going to be able to program that much faster because the design engineer gave you that ability to extract that information in the CAM side. It's huge, absolutely huge. So there I have a simple part. It's got 4 holes. It's a counterbore, 5/16 binding head machine screw. That was put into the CAD side. When we imported it into the CAM side, we could tap that information in a property page. And based upon that, how many of you guys know how you would want to manufacture those holes? Probably everybody. I'm going to do a pilot, a pack, a this, a that. It's going to be a multi-step process, right? And you're going to have multiple tools potentially as well. And that's important, okay? Guys, to give me what I need so I can make it go faster. And if I can do that and I can store as a group all the tools and the cycles I need, I'm not doing those one at a time, I'm doing them all at once. And I'm not doing it on 1 hole, I can do it on 50 holes at the same time. What do you get? You get automation, okay? It's simple automation. It's not scary, makes you more productive, less problems. Hey, if something goes wrong, it's the engineer's fault. But it works great, okay? But it is automation. So as a group, it gets applied. And in our world, certainly it calls the tools, it does everything that you might need. You can think of certain kinds of features on just about any part. You know you've got holes. You might have some kinds of contours, right? And you got pockets. So those are kind of feature families that you could tap into and help you automate another step. Another step. So if you do a lot of pockets, you do a lot of electronic housings, you do a lot of different things, you can start to build on top of your expressions ways in which to tap into that environment and be more productive. Here's some feature families. Very simple parts, holes, slots, pockets, okay? And even some, edge chamfering. The edge chamfering is a contour. It's a feature, a family of features, right? So here's the Marlboro Man of manufacturing. And inside of his head, and a lot of you guys, is a ton of information. I mean, a wealth of information. He's like 70 years old, he's just young looking. And he knows everything about his environment. He knows about what kind of machining cycles he's going to use on different kinds of materials, the tools, how he might grab a certain tool depending on the maximum radii, the minimum radii of a part in a pocket, feeds and speeds, blah, blah, blah. He knows all this stuff. Where does it live? It lives in his head. Can we extract it so that you can use it, and you can use it, and you can use it? So let's pretend he's our master. So we're going to talk about knowledge-based manufacturing now, a more automated level of it. So we already did a little bit of knowledge-based manufacturing on the other stuff, but now we're going to create a database. And the database is going to be pulled out of his head, put into an environment that he can use it. Maybe he's just the only guy in the shop, but so now he can tap his own stuff quickly, right? Or maybe he's got 3 young engineers or 3 young part programmers, millennials, and he is going to show them quickly how things are done because he created it. So he gets his information, he plugs it into a database. Believe me, I'm simplifying this to be understandable. And then these guys, when they're on the computer, they're going to tap that database and be able to program quicker. They're not going to have to reinvent the wheel because he knows what's going on. He's lived that life, okay? So the next thing you might say, okay, that's pretty cool. I'm a one-man shop, I'm a two-man shop. Well, I have end users that are enterprise-wide multinationals. I'll give you an example of a customer, 120 plus licenses. They serve everything out of Michigan, the database. They serve it to Czechoslovakia. They serve it to the Netherlands. They serve it to Brazil. They serve it to the US. They serve it to Mexico. They serve it to Singapore. Nobody touches the database except the master, or in this case, a group of 4 guys. So somebody in Singapore might say, hey, I think it would be better if we did this. And then they go to the group, or they go to the guy, and then he goes, yeah, I agree, let's change it. And then he changes it, and everybody starts using it that way. Now, you know what the politics of that can be like, right? It can be like an argument. So if you want to set up a database of knowledge, it can be, the toughest part is the politics of doing that. But it works, okay? It works. The company I'm thinking of that's got 120 plus licenses, they take it a little bit further. They buy all the same machines everywhere in the world. They use all the same tooling everywhere in the world. So they cover every variable they can to be more productive. Now, people dream about doing that. You know, logically you say, oh, we could do that, but you never do. These guys did it. It's quite interesting. Go Army. I'm involved with an Army group, Benet Laboratories up in upstate New York. They're attached to an arsenal called Watervliet. And we're in a pilot program. And our pilot program is for, it's called Smart Machining Solution, SMS. I hate acronyms, and actually in the back of our overview of this giant project, there's like 4 pages of acronyms. So because it's like they're always talking like that. I say, I don't know what you're talking about. Can you give me a glossary? So the center of this would be the CAM system, and it's talking to the machining cloud, which has a digitization of tooling catalogs, fixturing. It's talking to tooling optimization software. It's talking to tooling databases. And so the idea is create a lot of your feature family information knowledge base, be able to talk to all these other things, and you will be able to be more productive. And the guy who's actually the brainchild of this, and believe me, it's like a 6-year project. They spent a lot of money. It's only a pilot project, is that as you bring in young people into this manufacturing world, it's the millennial thing. How easy can we make it? Can we tap what our history is? And I talked about the one company in Wisconsin. They're not unique, okay? We're losing a lot of people. At the same time, in the world of politics, we talk about where are the manufacturing jobs? Well, there's about 500,000 manufacturing jobs today that are unfilled. So we gotta bring people in different ways. So the Army thing is really cool, and we're about 3 years in, and we got another 3 or 4 years to go. It's fun, but there's an idea. And they will, once they have that, start to migrate it to the other arsenals. It's being audited by some big manufacturers as well. General Dynamics is looking at it as something to potentially bring in and utilize. So let's go high-speed automation now. Black box. That's kind of fun and scary. Everybody know what those are? Yeah. That's that stuff, you know, like ClearCorrect Invisalign. So I don't really know how it works, but I know that you're going to have a series of mouthpieces, right? And each mouthpiece is based on your impressions, okay? So what can you do to automate that? How many programs do you think need to be cut per week to satisfy a certain size of people who are using those to straighten their teeth? Now, I always say it's an old joke. Nobody ever laughs at it. It even works in England. See, nobody laughs. You know, what's his name? Mike Myers did it. You know, it was the big joke in his thing. But you can bring in an STL file that's been coming out of that mold world. That STL file in a black box gets plugged in, gets positioned. You do rough, you do semi-finish, you do finish. And it spits out NC code. And there's a ton of machine tools out there to cut. How many? 10,000 a week? 20,000 a week? 50,000 programs a week. Now we're talking unique programs, right? Because everybody's set of teeth are a little bit different. That's where automation works. You can't have 10,000 part programmers cutting those things or programming those things. So automation works. It's pretty cool. I like it. Somebody will come to us and they'll say, can you guys do that? And they say, let's see. And it's fun because you get to produce something that's really, really unique. We have another one. And this one is, these guys make motor shafts. And the motor shafts, it'll come out of a CAD system to design. It'll get dropped into a directory. The software's listening in that directory. Is there something there? Okay, there's something there. It gets grabbed. It goes into the automated deal. The features get recognized. The tool path gets applied. The NC code gets made, depending on what features it sees and what machine tool it's going to go to, because those are still choices that need to be made, but it's made automatically. And then it queues it up into a direct numerical control system, and they just start running them. Now, it'll do a spectrum like this. Now, in the politics of the world, we did this for another company, and we say, okay, it works for this spectrum of parts. And the guy would always give it this one over here. And he would say, it doesn't work. Of course it doesn't work, okay? Don't give it that. But then it would fall apart. Why didn't he want to do it? He was afraid, which is okay. That's just how life is. I got two stories about this one. One is successful and one is, I find it interesting. No judgments on my part. I just find it interesting. Back in about 2000, we had a lot of software in an aerospace company, and the guys who programmed the wings, believe me, there's thousands of holes in the wings, okay? And there's a machine that's like a two-story machine. It goes along the wing, and all you got to do is give it two-dimensional coordinates, and it figures out the 5-axis vector. It's really pretty cool. And they say, hey, we need to help on programming the wings. And they give us something. There was PMI that existed. So each point was a drill hole of some type in a fastener. There was a key of, let's say, 10 characters, and those 10 characters would define the hole in the fastener type. Thousands of them. So we're in a meeting room, and a big conference room. There's guys around the conference, guys around the walls, and I ask a question. And the question I knew the answer to. And the question was, is there any kind of rules that you could set up to enable you to be more productive? And two people down on my side, the guy leans forward, and he goes, yeah, we could do all these things. It's really cool. And he's just like, he's young, okay? And the guy, two down from him, leans forward, and he goes, last in, first out. And he leans back. My wife's been in a union. She just retired. So I'm not complaining about unions. I'm saying that it's a people thing at times. Whether you're in a big organization or a small organization, what do you want to do to try to be more productive? Do you need to be more productive? Now, on that deal that we were working on, everybody got yanked off the project. Everybody. The directors, they killed it. And my take on it was just too disruptive, right? So a level of disruption they didn't want. We move on. It was a lesson learned. It was a union. There was two unions in that world. One union was an engineering union, and one engineering was the IAM guys. But it was cool. We learned. I'm not judging, by the way. I just thought, okay, there's challenges in manufacturing that sometimes I don't see because I don't live there. But there I saw. The other one was in the world of manufacturing airplanes, where the skin, I'm going to simplify it, where the skin meets the structure, okay, and this is probably not in the carbon fiber planes, there is a shim. There is hundreds and thousands of shims. There might be only 20 shapes, like top-down shape, but it's got to fit exactly in that gap between skin and structure. So they go out and they measure with a laser deal. So each shim, once again, top-down shape has that, and then maybe there's 3 points, 5 points, 10 points that they're going to measure and type in manually. And they're only Z values, okay? They're only Z values. And so they pick the shim, they know where it's going to go, they type in the Z values because they've already laser measured, and they get ready, they take a piece of aluminum, they put it on a vacuum table, they push the button, and it cuts the shim. The assembler, who's done all this work, takes it off, deburrs it, and he goes and puts it on the plane. What's the problem? He's not a machinist, he's an assembler. So I say to the guy, the R&D guy, manufacturing R&D guy, who was at that company, I said, can we go over and watch? He says, no. I said, why? He goes, they'll kill me. And he was half serious, but it's people, okay? So, what did I do? Oh, there we go. I'll just let this run for a second. The digital twin world is expanding, so everything's being digitized, right? And we're challenged with how much data we have to deal with in the digitization of our environments, whether they're inside the machine tool, in the computer, whatever. So you're seeing things like tooling catalogs being digitized in the CAM software world. There's more details, tooling, setup, everything to make sure that life goes well in that environment. And you're going to see a lot more of it. We stress out our computers because invariably they're too slow, okay? So, as people who might want to embrace automation, I said early on, is it about technology? And I think it's more about people. It's more about who's making decisions to do that, how far you want to go, who you might hire to be helpful to you, how you're going to deal with your futures. These are all the kinds of things that are part of a process that in today's manufacturing world, you're going to have to deal with one way or the other. And with that, oops, that's all, folks. Have any questions? I'll be glad to answer.